Okay, good evening. Welcome to Twitter Math 13. I saw this problem on Twitter tonight asking for different solutions to it, and I thought it'd be fun to go through. Mostly because in the geometry book I'm going through with my son right now, Art of Problem Solving Intro to Geometry, section 7.2, which we covered either last week or the week before, fairly recently, talks about perpendicular bisectors. So since it's in the beginning of the geometry book, I figured it's close enough. Hopefully appropriate for kids studying geometry. So I've got a circle and a square. The square has a side length 20, and the question is, when the circle hits the square like it as pictured here, what is the diameter of the circle? So what I would do here is I would draw in this isosceles triangle here that has a side of 20. These are going to be 10 and 10. 20, so the two sides of the isosceles triangle are going to be 10 times the square root of 5 and 10 times the square root of 5. Then what I'm going to say is the circumscribed circle of a triangle is the intersection of the perpendicular bisectors. So we know the perpendicular bisector, what I meant to say was the circumscribed circle, the center of the circumscribed circle, is at the intersection of the perpendicular bisectors. So we know this side here, 20, since it's an isosceles triangle, the perpendicular bisector comes straight down, and it happens to be the side of the square. So that's 20, and this is 10. And we have a 10, 20, 10 root 5 triangle. The perpendicular bisector here is going to hit here. And now, let me erase that 10 root 5 and put it on the outside. Sorry about that. 10 root 5 is the whole length. This is going to be 5 root 5. And notice that in our triangle, since this is a similar triangle here, that's a similar triangle to the big triangle, that we have the long side is twice the short side. So this is 5 root 5 over 2. And the hypotenuse is the short side times root 5. So I get 25 halves for the hypotenuse of that triangle. And sure enough, that's the radius of the circumscribed circle. That means the diameter is 25. So just by looking at the circumscribed circle and finding the triangle for which this is the circumscribed circle, you can find the diameter fairly quickly. A more advanced solution would use the one extra idea from the circumscribed circle, saying that the area of any triangle is the product of the sides, ABC, over 4 times the radius of the circumscribed circle. So here I know the sides of the triangle, and I know the area. Base is 20, height's 20, so that's 400 divided by 2, so the area is 200. It equals 20 times 10 root 5 times 10 root 5, all over 4 times the radius that we're looking for. So a bunch of things are going to cancel. Let's see, that 20 is going to cancel here and leave a 10. That 10 can cancel here with one of these 10s, and we get 1 equals 50 over 4 times the radius. So the radius is 50 over 4, or 25 halves, just like I said, so the diameter is again 25. So anyway, those are that's just a quick solution, a basic solution using the circumscribed circle, and then a more advanced solution using the area formula that involves a circumscribed circle. But I think that's a quick solution to the problem that I didn't see on the blog, so thought I'd show you real quick.